Apparently this end of the spoon is input. I don't know how we know, but according to Parapolylogic, this is supposed to be the input side, and that's the output side. Who dictated that that was so? That, right, I'm putting energy in, and that's my output. Oh, so am I putting energy in here? And that's the output there. Is that how it works? Where you press, even though it's a solid object, one object. So if I twist it in the middle, which side am I putting the energy in now, Parapolylogic? Am I putting it in that side or that side? Oh, that's right. I'm putting in the whole thing, like I always was. That's putting the energy in the whole thing. That's putting the energy in the whole thing. The whole thing has energy. That end doesn't have separate kinetic energies to that, just because that bit happens to be going a bit faster. Which bit? That bit, that bit, that bit, that bit. How do you work out which bit you're going to measure? That bit right at the tip, a millimetre in, or a micron in, or a centimetre in, or an inch in, 3 inches in, 6 inches in. The fulcrum is exactly 3 inches, 1, 2, 3 inches. And this side,
1, 2, 3, 4, 5, 6.
5 and 7, 8. So this is Gary's model, isn't it? It's just we haven't had to actually physically put the weights on. We haven't had to construct it, make it ourselves. This one was made out of one solid lump of metal, whereas this one we've had to stick the pieces of metal and plastic together to achieve the same effect. To call this a lever with an object there and an object there is just utterly ridiculous. It's crazy. That is one object. This is one object. This is one object which would model it similarly.
This is one thing. That is one thing. That is one thing. We've got one thing there at the back with the yellow balls and one thing at the front with the green balls on it. If I paint green balls here or yellow balls here, doesn't make this one thing into 3 things. Yeah, they're pendulums, aren't they? Yes, they're pendulums, aren't they? That's all they are. They're pendulums. It's quite interesting to watch. That is one thing. Each lever there is effectively one thing. Light at one end and heavy at the other end. But the whole thing, you have to look at the whole thing, Gary. Therefore it's invalid to say that one end has more energy than the other. The whole thing has energy. That has energy. You don't go around saying, well, my left leg has different energy than my right leg because it's going at a different speed. When one leg goes forward, the other leg's not moving. You don't go around saying, well, my left leg has different energy than my right leg. Hello again. Here we are again trying to explain to a moron how science works. Bear in mind that this was Gary's idea, not mine. Okay, so remember, this is Gary's idea, not mine. So remember, it was Gary's idea to hide half of the levers and for us to guess which one's which. Same test as before. On this side, the pool balls are in the same place. On the other side, one of them is in the same place. And in the other case, I'm not telling you which yet, it's half a pool ball. Twice as far away from the fulcrum. There's the fulcrum. Let you see that much. I've made it more solid. Last time was a little bit lazy, but I didn't think Gary was going to be a moron about it. So last time I'd used an elastic band. And so it wobbled a bit, and Gary tried to make an issue out of that, saying that that was the reason that they were oscillating at different frequencies. Absolute thick as a brick. So here we go again. Which one has the half mass ball twice as far away from the fulcrum? Which one is that? Half mass ball. Which one? I can tell. If you'd set it up, I could tell. Why can't you?
You obviously can tell. You just don't want to admit it. It's like me saying, I'm holding 3 fingers up or 2. And you saying, it's impossible to tell. Something wrong with you.
Let's move the screen out of the way then.
And apparently Gary, nor Polly, whatever his name is, or any of his other fans, can tell the difference, even though it's blatantly in front of their faces right now. In other words, they're lying through their teeth. They obviously can tell the difference. They cannot be. Nobody is that thick. 5-year-old kids aren't that thick. Dogs aren't that thick.
Well, if I count how many the front one goes, the green balls, until it comes to a standstill.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
10. So in the space of time that I did 10, see what the other one does. You ready? Counting the back one now.
1, 2, 3, 4, 5, 6, 7, 8.
Yeah, so the back one had done 8 by the time the front one had done 10. So when that side is covered up, anyone should be able to tell that the one that's moving the slowest has got the half mass twice as far away from the fulcrum.
But then, of course, Gary, being a lying, cheating scoundrel, decided to change the challenge from 2-to-1 ratio to 4-to-1 ratio and everything in between. He changed his challenge to try and make it more impossible. So let's have a look at that, shall we? This was the challenge he set up. This is the 4-to-1 challenge. He changed it, didn't he? He changed it from 2-to-1 to 4-to-1.
It's not possible because the whole way the lever works is that one side creates the energy for the other side's motion.
So that relates back to the spoon, doesn't it? You're supposed to be able to calculate, the extra kinetic energy at that end. Apparently, this end of the spoon is input. I don't know how we know that, but apparently, according to Parapolylogic, this is supposed to be the input side. How is that logical? Even though it's a solid object, one object. So if I twist it in the middle, which side am I putting the energy in now, Parapolylogic? Am I putting it in that side or that side? Oh, that's right. I'm putting it in the whole thing, like I always was. That's putting the energy in the whole thing. That's putting the energy in the whole thing. The whole thing has energy.
So the challenge was this. This was the challenge. If you don't know whether the weight is here, here, or here, and in these proportions, there's no way to tell over here. All feel exactly the same.
No, they do not. Only a moron would make such a claim, especially without testing it. Okay, so I'm going to be counting frames from here. 120 frames per second. Let go there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20.
21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49,
50.
51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76,
77.
78, 79, 80, 81, 82, 83, 84.
85. I think that's it, 85. I can see the line now on the left. Yes, it was 85 then. Okay, so 85 for the 1 mass example. Okay, so now we jump ahead to the 2 mass example. And that should be faster by right. See if it really is.
There you go.
Okay, we're counting from here. Well, when my fingers off. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29,
30.
31, 32, 33, 34, 35, 36, 38, 39,
40.
41, 42, 43, 44, 45, 46, 47, 48, 49,
50. 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63. 63. Okay, so yes, it's faster. 63 frames for the 2 mass example. There you go. That works out to 1.35 times faster. Beginning to spot a pattern here. Gary being wrong.
We've talked about this before. You just change the distance, so 2x the distance, and you can double the mass on one side.
What is it that makes him think he's an authority on this? When he's never even constructed this weird kind of lever. When he's never even attempted to construct a lever like he's drawing here. Well, here's my attempt to recreate the drawing that he's done there. So this is the lever, without any weights on it. A lopsided lever, and to make it still balanced, I've had to put extra weight in the short side, because he's drawn a lever which would otherwise have to be massless. And obviously no such lever exists.
There you go. And so I'll start with that end flat to the ground, okay? Then I'll let go. And we can time that. And you can see it's balanced at the top, mark there. The same as the top mark on there as well, the red, yes. So you can see they're balanced. And we can time that. Now I put the same amount of weight as there. So we can see by eye that this is moving much faster than it was when it had the 1 mass at the far end of the lever. We can see that that's moving much faster than in the previous case where we had a 1 mass 2 distances away from the fulcrum. So once again, Gary, it's moving faster. By the way, have you still not bought any scales, Gary? They're only a tenner.
Okay, I'm going to count frames from the moment my finger leaves the lever. Right, I can see a gap now, so count from here. This is in 120 frames per second, by the way. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. You can barely tell it's moving. It's like trying to start a car in 4th gear.
21, 22, 23, 24, 25, 26, 27, 28, 29, 30. 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82, 83, 84, 85, 86, 87, 88, 89, 90, 91, 92, 93, 94, 95, 96, 97, 98, 99.
100.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19.
20. So that's 1 full second to get that far. Start again now. We're into the second.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40.
I'm counting up to when the top marks of the cups are in line with the marks on the board. 41, 42, 43, 44, 45, 46. They're level now. I'm looking at the red one on the right. It's hard to tell with the blue one on the left. So I was looking at the red one on the right when that looked to be lined up. And now the same 2 mass on both sides of the lever, the same distance from the fulcrum. If you count the frames, you'll notice that it goes about 50% faster than the previous example, where we had the 1 mass twice the distance away from the fulcrum. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20.
21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82, 83, 84, 85, 86, 87, 88, 89, 90, 91, 92, 93, 94, 95, 96,
97, 98, 99, 100, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that was 110 frames to reach the same position in this case. Now, isn't that funny? That's a lot different than we had before. So here's Gary's lever, fulcrum. But this end of Gary's fantasy lever, as I call it, needs to be half as light as the other end. But in fact, it's twice as heavy. So this other end, the shorter end, is 4 times lighter than it should be. And so we have to add weight to compensate. There you go. That's how Gary's lever ought to be shaped, really. But that makes it pointless adding Gary's 1 mass and 2 mass weights on the ends, because it remains balanced the same anyway. It's already the scenario Gary describes. Twice the weight on one side as the other, but longer by twice as much on one side. The whole point of Gary's claim is that the 2 sides have the same momentum, and yet more kinetic energy on one side, B, than the other, A, because B is moving twice the velocity of A. But that only happens if we deliberately, momentarily change that balanced relationship by intentionally not placing the masses on at the same time. If we carefully place them on at the same time, the balance will remain. There will be no movement. When we don't place them on at the same moment, we no longer have the same momentum situation that Gary describes. Gary's describing a situation which isn't as stated. There is only movement in the system while Gary has upset the system by deliberately placing the masses on at different moments in time. The scenario that Gary describes can only happen if he upsets the balanced relationship by momentarily having the wrong weight on one side or the other for his same momentum situation to remain true. During that period, while the lever is not balanced, in other words, tip left or right, depending on which side he decides to unbalance first, that same momentum situation does not exist. The extra weights that Gary describes are a pointless addition. We don't need them. We might as well just rock the balanced lever that I've drawn here, and then make Gary's claim that the energy input is rewarded with greater energy output, according to kinetic energy rules. Now, we know that isn't really the case. Perhaps it's understandable why some people might think this end of the lever with half a mass, according to kinetic energy rules, has got twice the energy of that side of the lever, moving half the speed. It can't do anything but move half the speed of it. But then they take it one step further. They then jump to the wrong conclusion that the light end has gained free energy, not that the other side has lost energy to make the light end go twice as fast, explaining why the whole lever slows down. They forget that the whole lever slows down. Some people don't even realise the whole lever slows down. Gary certainly doesn't. Gary denies it, which is why I have to go to the trouble of showing you that it does slow down. They then say, in that case, this must have gained free energy from that because according to kinetic energy rules, this side has more energy than that. And they never stop to consider that this end, trying to obey kinetic energy rules, is effectively stealing the energy from this side. So it's not that this side has gained energy from this side, free energy from this side. No. It's more like this energy has lost energy to enabling this to go twice the speed of that side, demonstrating the fact that this side, which previously went quite happily at a certain speed, slows down when you balance it with a half mass there instead of a full mass there. Look, folks, Gary, for whatever reason, doesn't want to acknowledge that there is a difference. If he won't acknowledge that there's a difference, at least you can. There's nothing stopping you. You don't have to believe everything he says. You can use your own eyes. You can test it yourself, or you can see for yourself that it does slow down. It doesn't behave the same when it's balanced the two different ways. That's where Gary is fundamentally wrong. Imagine it was yourself that you did these tests, and if you miraculously get some other results, you need to go on TV on a talent show and show you breaking the laws of physics. Think for yourselves. Seriously, folks, please start thinking for yourselves. It slows down. Why? Because this side that you say is supposedly, according to kinetic energy rules, gaining free energy, it isn't gaining free energy. It's this side that's losing energy to the task of making that go twice the distance in the same amount of time. Please stop the recording at this point and think about that. Go back the last few seconds and think about what I've said because it's correct.
This is one thing. That is one thing. That is one thing.
The whole thing has energy. How you divide an item into little amounts of energy so you can manipulate the figures and make it look like magic is happening within that one object. Because these really are one object each. Just because there's two balls on the end and they're glued to a stick doesn't make that three things. It's one thing. It's one item. You glued it together. They aren't actually being launched off the lever, Gary. When you do that, the dynamic situation changes completely. I'm going to click through one frame at a time. You can see the ball on the left dropping. Yes, so it's launching into the air. Yes, yes, yes. It's going. Oh, sadly. Chucking it over the edge there. So it's launching it. Throwing it out of the side. Oh no, it's coming back down. Is it going to launch the other one? It's coming back up. Coming back up. Coming back up. Oh. But it obviously didn't have enough energy. It had enough energy to rebalance it, but it didn't have enough energy to launch the heavier mass back in the air. Right, so it's launching the yellow. Oh, it's always one of it. It's coming back down and lifting it up again. But not enough to relaunch the initial ball. I'm not entirely sure what the point of this is, to be honest, but you know, this is something that Gary has been talking about over the last year, so why not? Oh, I'm just adjusting the height a bit, so the yellow ball isn't going to get thrown sideways quite as much. Here we go. Oh. There we go, launching the yellow in the air. Yeah. Destroying my house. Coming back down, but the trouble is, it's broken off.
Hey, that was a good one, wasn't it?
That's the one we want to look at. That's the one we want to look at now, this one. That is a good one, isn't it? That's kind of an instant. Anyway, so we can see it going in the air. It's gone up quite a way. Yes, that's good. It's going to come back down now. Oh. What's happening now? Come on. It didn't actually launch the other one though, did it? It just... Oh, I was trying to do it the other way around once. I was trying to drop, yeah, I was dropping the yellow ball straight into that right hand. Okay, look, this video is long enough already. I've got tons and tons more of this lever. I've got tons more of this lever stuff to show you, different levers and all sorts of things. Trebuchets and God knows what, and accelerating motors, and I can't cram too much into one video. It's going to bore the out of you. So I'll let you go with that. Thank you for watching. Oh, so there's quite an intellectual, academic discussion going on about, well, apparently it's supposed to be about levers, but I'm not entirely sure it is, because here we have a spoon supposed to be able to calculate, you know, the extra kinetic energy at that end, and how apparently this end of the spoon is input. I don't know how we know that's supposed to be the input side, but apparently, according to Parapoly, this is supposed to be the input side, and that's the output side. How is that logical? Who dictated that was so? Right, I'm putting energy in, and that's my output. Oh, so am I putting energy in here, and that's the output there? So if I twist it in the middle, which side am I putting the energy in now, Parapoly? Am I putting it in that side or that side? Oh, that's right, I'm putting it in the whole thing, like I always was. That's putting the energy in the whole thing. That's putting the energy in the whole thing. The whole thing has energy. That end doesn't have separate kinetic energy to that, just because that bit happens to be going a bit faster. Which bit's that going a bit faster? That bit, that bit, that bit, that bit. How do you go about calculating the kinetic energy of that side? How do you separate, how do you work out which bit you're going to measure? That bit right at the tip, a millimetre in, or a micron in, or a centimetre in, or an inch in, 3 inches in, 6 inches in. The measure to the fulcrum there, one. So the fulcrum there, oh, it's got 3 inches, 1, 2, 3 inches. And so this side, 1, 2, 3, 4, 5, 6.
Startle, starting night. Little flowers and rounded blows. Swirl the clouds about the top. Red, fluffy, vegetable, the tiny blue. Just a minute, I swear it's going to be a little type, so it's a little time. Startle, starting night. Lemon flowers left right. Swirling clouds of colors, it's a thousand of blue. Colors changing your morning face. So the panels open the doors. Put your dreaming still.
Of crap, but I feel like we've thrown the baby out with the bathwater. When I looked at the long discussion, that's 40-odd comments so far between
mainly Mindless Marbles and Parapoly. I think, what's this discussion even about anymore? It seems to have turned into some weird academic thing, going back to Archimedes and or whatever. Well, who gives a shit? It's a fucking spoon. Okay, so I can't remember who it was who laid out the rules. Said, right, we will calculate the kinetic energy in this thing here. Well, go on. You're quite welcome. You're very welcome to go about calculating the energy at that end and that end. I'm dying to see how you go about doing it, seeing as you don't know where to. How do you go about doing that? Supposing this weighed 100 grams. I don't know what. Let's just go. Got a similar spoon here. Let's get an idea how much that one weighs. I don't want to take it off because I might spoil the pivot, but oh yeah, I wasn't far off. This one weighs 105 grams. So this one, let's say this one weighs 100 grams too. Okay, 100 grams. Now, what are you going to do? Are you going to say, well, this side weighs 66 grams and that side weighs 33 grams and we're going to allow 1 gram for the lever itself element because don't forget, if this weighs 58 grams and this weighs 116 grams, and the lever itself weighs 20 grams, that's 194 grams, I seem to remember. You have to take account of the actual weight of the lever, don't you? The lever, that it isn't massless, is it? But if you just divide this into thirds, weight-wise, mass-wise, and say, right, well, this is 66 grams, and that's 33 grams. Well, you're effectively pretending you've got a massless lever, aren't you? How stupid is that? So you would have to account for some element of it being the lever. Let's say 10 grams. So if we take out 10 grams of this and say, well, 10 grams of this must be the lever element. So we're left with 90 then. In which case we would say, well, let's say this side is 60 grams on this side, and this side will be 30 grams. But you've got another problem now, haven't you? Because the shape isn't exactly... It isn't this lovely, neat, uniform. Well, actually, this isn't that neat and uniform. If you cut 60 grams worth of this off, then that part is going a different speed to that part, and different speed to that part, and that part, and that part, and that part. The speeds are varying all the way along. The width of the material is varying all the way along. The thickness of the material is probably varying all the way along, assuming these have been stamped. You know what I mean? It's silly. This has got a hole in it there, so, you know, but for hanging, it's on a hook. And yet this is the same thing that we're all arguing about. We're supposed to be able to say, oh, we input energy there. Bonkers. No, we don't fucking input energy there. Parapolylogic keeps saying about the small mass. What small mass? There isn't a small mass. There's one mass, 100 grams, the weight of the whole fucking thing. So all this listing the small mass. Did anybody mention the weight of the lever, by the way, in these cases? I don't remember if they did. Because that might have got ignored somewhere along the way. I didn't take too much notice looking in those calculations, but I like to think that somebody did have the intelligence to include the mass of the lever itself. And what about the overhang? What about the overhang? Because to model Gary's lever, you don't need that bit of the lever. That bit serves no purpose, does it? You know what I mean? That bit only serves a purpose when you take these things off. But that's a different thing altogether. So what about the overhang? Why are we leaving that on? Because that's altering the mass of this effectively. It's not really a 2-to-1 ratio thing, because it's 2-to-1, but brushing this bit under the carpet, pretending this bit doesn't exist. But it does exist. We should hacksaw that bit off and then do the bloody calculation. In fact, we should make this out of nothing. This lever bit, we should make it massless. I think that's what we should be doing, folks. If we're taking Gary's argument seriously. Gary, who thought that clay was measured by depth. Gary, who thought, and Parapolylogic, both thought, really genuinely thought, even though they'd been studying this for 2 fucking years, believe it or not, pretending to, lying fucking bastards. Only last week did they declare that they'd seen a TV entertainment program, an El Cheapo stupid TV entertainment program, no more scientific than fucking Top Gear, and they were using clay the wrong way to determine the kinetic energy of a 100-mile-an-hour car and a 50-mile-an-hour car. They were squashing the clay. They weren't measuring the volume displacement of the clay, which is what Emily du Châtelet did, which is what Willem Gravesend did. This is what the actual qualified people who've made videos about the clay experiments on YouTube actually did. Not the stupid Hollywood movie about Einstein where they just got some runners to say, oh, go and construct an experiment, but it's just got to make it look like the ball has gone twice as deep. And so they've knocked together that they faked an experiment just for the visual effect, and that's fine as long as the intelligence of the people watching it isn't so low that they think that this is a documentary, educational piece. No, it's edutainment, isn't it, as they call it? It's half entertainment and half education. It's neither one thing nor another. They're having fun with it, which is why they show Emily du Châtelet as this gorgeous woman that I'm sure Emily du Châtelet didn't really look like that. Dropping lead balls into clay. And the Oscar goes to Steve Bruff for showing a spoon wobbling up and down his Gary's demonstrations how kinetic energy isn't a real thing. Utter fucking moron. Parapolylogic. Utter fucking moron. See, I wouldn't mind if somebody like that had simply said, look, I've seen this TV entertainment program, Mythbusters, where they seem to come up with a different result. But no, didn't do that, no care whatsoever, just declare, proves beyond all doubt that the kinetic energy formula does not work out, that the clay gives 2 times depth deformity, not 4 times. Well, it never was meant to go 4 times depth, you stupid moron. Anyway, a spoon. Why are we even discussing this? Should I chop the spoon up into little bits? Will that satisfy you? Then you can say, oh, right, now that side has a certain amount of kinetic energy. Now that's a... But where do you measure it from? There. It's a stupid facile argument. I'm sick up to the back teeth of it.